Hello guys, welcome once more to Prepclass online class, and my name is Mr. Damdula. In this video, we shall be looking at physics past question, WAEC past question number 26 to number 30. If you like this video, please don't forget to like the video and also to subscribe in the link below, in the port below. So let's check out the question 26 to number 30. WAEC 2019 past question. This says an AC generator can be converted to a DC generator by replacing the what? So what needs to be replaced? Okay, A, the commutator with an armature. B, armature with a commutator. C, commutator with a slip ring, with slip rings, please. Then D, slip rings with a commutator. Now, first of all, you have to know this question is talking about a generator. Now, most of us have generator at home, but there are principles for the working of a generator, and there are two major types of generator: AC generator and DC generator. You know, AC means alternating current, while DC means direct current generator. So we have those two types of generator. But you know, what is, first of all, let's define what's a generator. A generator is that which converts, okay, mechanical energy to electrical energy, you know, and the opposite of that of a generator is that which converts electrical energy to mechanical energy, and that is a motor, an electric motor. So motor generator changes what's it called, mechanical energy to electrical energy. That is a generator. While a motor changes electrical energy to mechanical energy, and that is an electric motor. So electric motor is the opposite of electric of a generator. So you must keep that in mind, because there are some past questions that ask that question. And now, what's a DC generator? It's a generator that that makes direct current. And what's the direct current? It's a current that flows in one direction. Okay, while AC current is a current that flows in two directions. That means both up, forward, like flowing forward and backward, and there are things that cause it. Now, this question is asking that how can we change an AC generator to a DC generator? That means there are pathways. Now, you can change an AC to a DC generator. Now, how? Is it by replacing the commutator with an armature, okay, or armature with a commutator, or commutator with a slip ring? Then slip ring with a commutator. So which of them do you? Now we have to explain some of these terms. Now you can see we have commutator. Now, but first of all, you must know that commutator is only available in a DC generator. Okay, and commutator, but in an AC generator we have slip ring. Now, instead of commutator, AC has slip ring, while DC has commutator instead of slip ring. So if someone asks you what's the difference between a DC generator and an AC generator, it is commutator and slip ring. Okay, now and that brings us to the answer to that question. How do we change, okay, an AC to a DC? Now, it's by changing the slip ring to a commutator. That's removing the slip ring and changing it with exchanging it with a commutator. Then that AC generator is now a DC. Then if you remove the commutator and change it to a with a slip ring, then the DC generator is now an AC. So it is just an interplay of commutator and slip ring. Now you must know that commutator is that which makes a DC generator a DC. Without commutator, there is no DC generator. Because for us to have a direct current, that's current flowing in one direction, it is the function or the work of the commutator. While for us to have current flowing in two directions, it is the work of the slip ring. So what makes the AC generator an AC gen is the slip ring. So if you remove it and you change it with a commutator, then you have changed the AC into a DC. Okay, then a DC gen, when you you know, it flows in one direction, current flow in one direction. So if you remove the commutator and you put a slip ring, then you change it into an AC from DC. So the answer to that question is, for you to change an AC to a DC, exchange a slip ring with a commutator, then it will be altered. Okay, so that's the answer. Then one other difference between AC and DC is the brush. You know, the function of the brush is that in a DC there is a brush. Sorry, there is no brush, but in an AC brush is present. Okay, so in a DC there is no brush. Another difference is that in a DC there is no brush, but in an AC brush is present. And the work of the brush is to help to connect the wire to the commutator or to the slip ring. So without the brush, there will be no connection between the coil or the source of current and the slip ring. So that's different. So generally, if we were asked what's the difference between a DC and an AC, number one, DC moves direct current, means direct current, that means current flowing in one direction, while AC means current flowing in two directions. So that's the difference between the two generators. Now number two is that a DC has a commutator, which means the current flow in one direction. Then AC has no no commutator but has a slip ring. Okay, which means the current flow in two directions. Good. Another difference is that the third difference is that DC has no brush, which is a source of connection to the like in the case of an AC, is the slip ring. The brush is a source of connection to the slip ring. So DC has a brush which connects the current to the slip ring, but AC does not have any brush. That is the difference between a DC and an AC. So the answer to that question is that slip ring, for an AC, you have to remove the slip ring and connect a commutator. So once you change the slip ring to a commutator, then AC generator has changed into DC. Very straightforward, right? Now let's check out number 27. Number 27 says, which of the following statement is the correct reason for using soft iron in making the armature of an electric bell? Do we have electric bell at home? Do you have one? Now electric bell, you know those electric bell, bam 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 bam. Now inside the electric bell you use soft iron. Now let's break it down. Now what is soft iron? You know, soft iron simply means something that doesn't have strong magnetic power, or that can easily gain or lose its magnet. It's called soft iron. Soft iron is a magnet, is a weak magnet kind of, but it's a magnet that can easily be magnetized, okay, and demagnetized. Okay, so now let me read from here. Electric bell is based on the principle of electromagnets. Okay, when switch is pressed, electromagnet is deactivated and the hammer moves. Now this is just trying to explain how the electric bell works. Okay, now you know when you press the bell, it will ring, right? Now the reason why it rings is because it has a soft magnet, and a soft magnet is something that it was magnetized and easily demagnetized. Okay, and why is it something? Why must it be soft and not strong or hard magnet? And the reason is because if it is hard magnet, it can be, once it is not easily magnetized and not easily demagnetized, so it's not best for an electric bell. Imagine a bell that you have to press so much before it can ring. That is what a hard magnet is. Hard magnet can't easily be magnetized, so it can't really function well. So, and if you now press it and it start ringing, you can't easily stop it from ringing. So the hard magnet won't really work for us to make an electric bell. You need something that can easily be magnetized, gain magnetism, and lose it fast. And that is why we use a soft magnet. Now, for this to work, a magnet can easily magnetize and demagnetize is needed. This is called a soft iron. So this is called a soft. So we need to use a soft iron, okay, to make that work. We need to use a soft iron. Now, as the hammer moves, circuit break, and now this is just trying to explain. Now we have hammer in that drawing. Looking at that drawing, we have hammer. So when you press it, the hammer hits the gong, and then the circuit break. Okay, now that means it will stop ringing. Now, if you leave it, the hammer, everything will connect again, and it will start ringing. So that's the way the electric bell works. So you need to work with you need a soft iron, something that can respond fast and stop responding fast. That's why we use a soft iron. So the correct answer to that question is therefore option B. It loses its magnetism readily or quickly. Okay, A says it is a diamagnetic material. Yes, actually, that's not correct. That's not the correct answer, and that's not the reason why we use soft iron, because it is a diamagnetic. You know, diamagnetic means it has two poles. Okay, but that's not the reason why we use electric bell. The reason is why we need something that can easily gain and lose magnetism, and that is the answer to that question. Okay, good. So let's check out number 28 now. Number 28 says do a drawing, and that's this drawing is a meter bridge, as you can see. Now the diagram above illustrates a meter bridge, okay, circuit under balance. Determine the value of x. Now there's one formula, mighty formula for this kind of drawing. When you see this drawing, don't forget this formula. To find to answer question on meter bridge, you need to memorize this formula. R1 over L equals R2 over 100 minus L. Now my R is my resistance and my L is my length. Once you know this formula, then you are now a master of any question on meter rule circuits. Okay, do you get that now? R1 over L equals R2 over 100 minus L. Okay, good. So let's look at the question. Now we are trying to, the question is simply saying that we should find the value of x. Actually, that x represents my L. That's the position of the length. Okay, so let's find the value of the length. So we have to make the length the subject of formula. Okay, so make the length the subject. Now, how do that? We have to cross multiply. That makes R1 bracket L 100 minus L equals L R2 L R2. Okay, good. So let's now multiply into the bracket. You now have 100 R times 100, making 100 R1 equals R1 times L R1 L equals L R2, right? Right? Good. Now the next thing, we are trying to make L stand alone. So bring the two L to one side. So we have 100 R1 equals L R2 plus R1 L. Okay, now L is common, so factorize. So since L is common, let L stand out. So L equals R2 plus R1 on the left, on the right hand side. So we have 100 R1 on the left hand side. So now we put the remove divide both side by R2 plus R1. So that the R2 and the R1 will leave the L alone. So when they leave the L, they will just go under the 100 R1. We mean L equals 100 R1 over R2 plus R1. That is called subject of formula in mass. So now the L is standing alone now. Now we have to find the length. Now we have been given R1 as 2 and R2 as 2. So we have substituting to that formula. We have L equals 100. R1 is 2 times 2 divided by 2 plus 2. That's R2 plus R1. So giving me 100 times 2 is 200 divided by 4. And that gives me 50 meters for my length. Now, don't forget the answer is 50 meters. But if you know that formula R1 over L equals R2 over 100 minus L, then you've gotten the 2 to use to answer any question on meter rule circuits. Once you know that, then you are a master of it. So we have 50 meters as the answer to number 28, and the answer is therefore 50.0 centimeter. Good. Now, let's check out number 29. Which of the following devices is used for storing electric charge? Now, is transformer used for storing? You know, storing. Do you use transformer to store charge? Do you think so? Now, ammeter, potentiometer, capacitor. This is very straightforward. This is very easy. Now, transformer is not used for storing charge. It's for stepping up and stepping down charge. So, transformer is the wrong answer. Then, ammeter. Do we use ammeter for storing charge? Do you think we use ammeter for storing? Now, look at everything. We have a transformer. Transformer is for stepping up and down a current. Then ammeter is for measuring current. Ammeter is not for storing charge. It's just, you know, whenever you hear the word ammeter, you know, current is measured in ampere. So using an ammeter. So good. So current measurement tool is ammeter. While potentiometer, from the word potential difference. So it measures electric potential or voltage. So potentiometer is used to measure potential difference, or electric potential is still the same thing as voltage. So what do we use transformer for? Generally, step up and down current. Ammeter for measuring current. Then potentiometer for measuring potential difference or electric potential or voltage. You are saying the same thing. Good. But capacitor is used simply for storing charge. So the answer to that question is simply capacitor. It's used for storing charge. Full stop. Nothing more, nothing less. So don't forget that capacitor is used for storing charge. And that is the answer. Option D is the answer to that question. And let's check one more before we end it now. This one says an electron of mass 9.1 times 10 per minus 31 gram moves with a speed of 2 times 10 per 6 meter per second around the nucleus of an atom in the circular path of radius 6.1 times 10 per minus 11 meter. Determine the angular speed of the electron. Now, when you see this kind of question, some people's heart will leap. Oh, this is a serious problem. What will I do here? Now, you just have to be familiar with someone, and that's one of the reasons why we make this kind of video, to make you familiar with some of the past questions, because actually some of them need explanations that are deeper than just the surface explanation that past questions can give. But you need to know the main point. That's how do they come toward it. Now let's take a look at this one. Now this one says that we have different options. Now for you to find angular, now this is a question under circular motion. Now which says that the formula to use whenever you hear the word, look closely at the question. It said it gave you a mass, it gave you velocity, that's speed, and it gave you radius. Now when you see the word radius and speed working together, and you see angular speed, anything angular to remind you of circular motion, because there is no other place where we have angular speed in all of physics outside circular motion. So the question should remind you, oh, this is a circular motion question. And whenever you are dealing with angular speed, simply means angular velocity. Okay, but we can't really find angular velocity without first finding, angular velocity in circular motion is represented by W. W means angular velocity. Now look at what I did now. I said velocity is equal to angular velocity times radius. Okay, now that's the formula to use. Now the relationship between linear velocity, that's normal velocity v, and angular velocity is just this formula. Once you know this formula, you've known the main formula to use for most questions on circular motion. But there are some formulas that one must never forget, because there are many questions on circular motion in physics, but this formula owns it all. Apart from centripetal force, this formula is the second strongest formula in that topic, angular motion. If you know this formula, then you've really know something key that will help you in your journey in circular motion. V equals WR, and my V is my linear velocity, of course. My W is my angular velocity, and my R is my radius. Okay, so let's find the W. So making the W the subject, I will divide both sides by R. So W is equal to V over R, right? Good. Now let's substitute. I was giving my V as 2.0 times 10 to the power 6. Okay, my R as 6.1 times 10 to the power minus 11. That's not my problem. Now don't see that I'm get scared. That's not a problem. Okay, good. So we have W equals V over R. Substitute my V 2 times 10 to the power 6 over 6.1 times 10 to the power minus 11. Now deal with that 10 separately. Deal with the number. I always tell students that don't solve the 10 and the number, that's the part of 10 and number, in any calculation together. So that's what I did now. Now I just did 2 divided by 6.1. That's 2.0 divided by 6.1, and that gave me 0.328. You must undo numbers separately, then undo the power of 10 separately. So now 10 raised to the power 6 divided by 10 raised to the power minus 11. By law of indices, division is minus in the power, so it will become 10 to the power 6 minus 11. That the first minus is the division. It will become 10 to the power 6 minus first, that's for division. Then 11 as a minus, that will become minus 6 minus then minus 11, giving me plus. The two minus will form plus. I will say that again. The first minus is for the division, and the second minus is in the question. Okay, so I have 10, 6 minus 11, giving me 10 to the power 6 plus 11, giving me 10 to the power 17. So I have 0.328 times 10 to the power 17 as my answer. But I have to guarantee that is not in the option. So I have to bring to standard form. That will give me the 0.328 will become 3.28. That point will move backward. Okay, then times 10 to the power, instead of 17, you have to minus 1. Whenever you move to the right, you have to minus 1 from the power of 10. That will become 17 minus 1, and that will become 10 to the power 16. So that will become 3.28 times 10 to the power 16 rad per second. That's the unit of angular velocity, and that's my answer. And that makes option A to be the correct answer. Now don't be scared. Next time you see angular speed and you see velocity, just know the formula to use. V equals WR, and that is the strongest formula, the second strongest formula in circular motion. Don't forget that. Now that brings us to the end of this section. Don't forget to like and to also subscribe in the link below this video. Until we see next time, take care of yourself for now. Bye for now.